Hey Bengals, this is Ms. Timmons. Welcome to Atomic Structure, Objective number 2. In this objective, we're going to be talking about weather and climate. We have a lot of information to go through, so if you haven't set up your Wix just yet, go ahead and pause, take a second, and set up the questions, and be prepared to kind of pause along the way, because I'm going to go through a lot of information pretty quickly. So let's begin. So to start out with, we need to talk about the difference between climate and weather. So climate describes the average weather pattern in an area over many years. So to describe a climate as being both cool and dry, that's very generic, very general terms. It doesn't describe the day-to-day, whereas weather does describe the daily changes within the atmospheric conditions. So rainy, stormy, windy, all of those would be characteristics of weather. So when we talk about weather, there are several things that will influence the average weather patterns in an area. So we're going to kind of talk about some of those factors. Those factors include temperature, whether it's hot or cold, precipitation, whether it's wet or dry. So in terms of temperature, temperature can be affected by the latitude, meaning how far a location is from the equator. Typically along the equator, the average temperature tends to be hotter, whereas farther from the equator, closer to the pole, the temperature tends to be colder. Elevation or altitude is described as the vertical distance above sea level. So this means how high are you above sea level. Sea level is 0 feet. That's where the oceans meet the land. And the higher up you go in elevation, the colder it tends to be. So closer to the coast, it tends to be hotter. Tops of mountains tend to be colder. And that's actually because the air is thinning out the higher you go in elevation. So it's not able to hold on to as much heat as the molecules get farther and farther apart from each other. So kind of considering those two factors and what is influencing temperature, let's take a look at two locations. We have Seattle, Washington, and we have Los Angeles. Now both of them are fairly close to the coast, but there are a couple factors that are going to, or there's one main factor that's going to influence its general temperature, not altitude, because they're probably both close to sea level, but Los Angeles is closer to the equator. The equator is at 0, which would be further down underneath the map. And Seattle is further north, closer to the pole, which means Seattle is colder and Los Angeles is hotter. So then let's talk about some other factors. Let's talk about how water impacts temperature. Water actually does what we call moderates temperatures. And what that means is that when there's a lot of water in air, it requires a lot more energy to heat it up and to cool it down. So areas that tend to be very humid are going to heat up slower, but they're also going to cool down slower. So if you compare Galveston, which is historically very humid, to the Sahara Desert, which is very dry, Galveston is not going to experience a whole lot of change between their temperature in the daytime versus the nighttime, or the summer versus the winter. So that means winter doesn't get near as cold and summer doesn't get near as hot if you live right next to the water. By contrast, the Sahara Desert, because it's so dry, the air can heat up very quickly, but it can also cool down very quickly. And because of that, they have very extreme daily temperature fluctuations. It can be over 100 during the daytime, and it can be in the 40s and 50s at nighttime on the same day, simply because the air is so dry, so its temperature can change very quickly. So then we need to talk about what affects precipitation. A couple things. Location, meaning how far you are from a coast. The closer you are to the coast, the wetter your climate's going to be. The farther you are from the coast, the drier it will be. When it comes to mountains, if you live in an area that is between the coast and the mountains, you're going to get a lot of rain, because a lot of times the rain is too heavy to make it over the mountain range. So it will dump all of the rain before it goes over the mountains. If you live on the other side of the mountain range, however, because all the rain tends to fall on the coastal side, the opposite side tends to be extremely dry because all of the rain falls on the other side of the mountains. And then the last one that affects precipitation would be the wind direction. So this impacts us a lot here in Houston because if the wind is blowing off the water, meaning off the Gulf, coming out of the south for us, that means our day is going to be wetter. It's going to be a lot more humid. Chances for rain tend to increase. Whereas if the wind is blowing off of the land, so coming from the north for us, that means the air is going to tend to be drier and there's less of a chance to rain. So now let's take a second and talk about air pressure. Air pressure is a column of air that pushes on everything from every direction. But due to gravity, air pressure is actually greater closer to the surface than it is the higher up you go in elevation. This was what I was talking about when I mentioned the fact that the air molecules will spread out. The closer you are to the Earth's surface, the more condensed they are because of gravity. Because of this, the higher you go up in elevation, the less pressure, the less air pressure you're going to have, versus as you go down low in elevation, close to sea level, you're going to have a much higher amount of air pressure. This is also compounded by the fact that whenever air is cool, it's extremely dense, and that will also increase pressure. Whenever air is warm, it has a very low density, and that will decrease pressure. So now let's talk about weather. There are three things that really impact daily fluctuations within weather. Pressure systems have a big impact on whether it will be sunny outside or whether it will rain. Convection currents will help influence the motion of both pressure system and fronts, but also direction of wind. And then the weather fronts, whether it's a cold front, warm front, occluded, stationary, all of those will kind of dictate what the weather will look like in that area. So let's start with wind. Wind is air that moves from high pressure to low pressure, always from an area of high pressure to an area of low pressure. Think of it like going from an area that's really, really crowded and trying to move to an area that's not crowded. So they always move from that high pressure, the really crowded space, towards a low pressure where it's not crowded. The reason for this is they're trying to balance out the pressure between these two areas, so air will move to try and create this equilibrium until the pressures equalize. What this looks like is you have cold air that's sinking. This is your high pressure center. High pressure actually causes your overall weather to be very calm and clear, and that's because as the air sinks, it kind of pushes all of the humidity, it pushes a lot of things out of the way. And because it's cold air, there's not going to be a whole ton of humidity. It's going to cause your weather to be both calm and clear. Very sunny weather is associated with high pressure. Whereas on this side over on the left, you have low pressure, and low pressure is associated with warm air rising. Low pressure days are actually days where rain is possible. It's more likely to be stormy, it's more likely to have cloudy weather. So we said wind moves from high pressure to low pressure area. The greater the difference between high pressure and low pressure, the stronger the wind. If there's a really small difference, then you're going to have just a gentle breeze. So let's kind of take a look, and we'll do a little bit more with this in class. But this is what's called an isobar map, and an isobar map allows us to calculate or kind of figure out where the high pressure centers are and where the low pressure centers are. And the way they do that is they create kind of areas. So these are all a pressure of 1020 and then 1024 and 1016. They would kind of connect the dots and figure out where the numbers are the highest and where they are the lowest, and then based on that information figure out what the weather would be like in those areas. So this is kind of what that might look like if you connect all the 1020 or 1024s, 1020s, 1016s. And again, we'll kind of touch base with this again in class, but I just want you to see it. Convection currents. Convection currents will cause two things. There's what's called a land breeze and a sea breeze. This is only in coastal areas, so areas that come in contact with water. And I'm just going to go over this very briefly, and we'll talk more in class. But you can kind of see how during the daytime you have one type of breeze because the convection current will rotate in one direction, but in the nighttime it'll switch, and that has to do with how quickly and slowly the ground can heat up versus the water. There's kind of another graphic, and we'll touch base with this in class. And there's your daytime. Alright, so let's take a few minutes and talk about weather fronts. There are 4 types of fronts that we're going to talk about: a cold front, a warm front, an occluded front, and a stationary front. So cold front, and this is one that you need to define in your WICS. A cold front is fast-moving, cold, dense air that moves into an area of warm air and rapidly forces warm air up. Big things that you need to understand with cold front. Number 1, this is the symbol. Number 2, they move very quickly. Because of this, cold fronts are usually associated with stronger thunderstorms. Warm fronts can create rain, but they're not typically going to create thunderstorms with lightning because they move a lot slower. So cold fronts can typically spark thunderstorms. A warm front is a slow-moving air mass. It moves into an area that was colder, so it's going to leave warmer temperatures behind it. It gradually pushes in. It can create rain, but they tend to last for several days rather than being very quick, hour-long, couple-hour storms. Your symbol for a cold front is up here in the top corner, so you have the red line with the circles. Stationary front. This is actually where a cold front and a warm front run into each other, and as they run into each other, they end up getting stuck. So on the back side of the warm front, you have warm air moving. On the back side of the cold front, you have cold air moving, and they basically get stuck there, and the front doesn't move for several days. It can rain right along this boundary, and that rain tends to kind of hang out. It's not very violent storm, it's just kind of slow showers over a series of days. The last front we're going to talk about is the occluded front. This is a fast-moving front that catches up to a fast-moving cold front that catches up to a warm front. And this can happen in one of 2 ways. They can catch up to each other parallel, to where you have one line with both shapes on it, or they can catch up to each other in a T-shape. When they connect with a T-shape, that is where you're going to get your most violent thunderstorms. So you kind of look for those on weather maps. If you see a T-shape with a warm front and a cold front, thunderstorms and pretty violent thunderstorms with lots of wind are much more likely. These are also conditions that can lead to things like tornadoes. Alright, last item before you get to your action item. Global wind patterns. I'm only going to touch on this briefly. So global wind patterns are these large belts of wind, or they're called the generic wind patterns, that occur in different latitudes across the world. They're named by the direction that they moved. So if you look right here, this is the northeasterly trade winds, which means in general, wind in this part of the world between the equator and 30 degrees north tend to move in an easterly direction. However, you go between 30 and 60 degrees, and the wind tends to move in a westerly direction. So they're named based on the direction they're going. The southern hemisphere will kind of mirror what the northern hemisphere is doing. That is all for today. Make sure you take care of your action item. Compare the